Hello, students. Um, we are going to discuss about design of a water tank in this video. So basically, water tank is a structure where you normally store the water. That water can be elevated, or can be underground, or it can be on ground. So the main purpose of storage of water tank is for drinking. It can be for an industrial use. It can be a fire safety. It can be of a processing unit. It can be of a multi-purpose. It doesn't mean that you are storing water for only drinking. So we'll discuss one by one what are the forces which are acting. What is the failure criteria in order to calculate the steel, and we'll discuss about on ground. We'll discuss about overhead tank. Overhead tank is not included in this video, but we discuss about on ground tank also. So if you want to classify the shape, if you want to classify the water tank based upon the shape, normally if you have a circular tank, then we call it as a circular tank. If you uh, if you have a spherical type, then it's called as a spherical tank. Then you have a spherical tank with a cone bottom. It's called inch tank. If you have a rectangular shape, then it's called a rectangular tank. If you have a circular shape with a conical bottom, then it's called as a conical bottom. So the normal general principles are nothing but a set of guidelines for the construction of water tank, because you are retaining water. So, and when it fails, it can be very catastrophic. It may be of a life loss. So, the main two the points which I would like to discuss in this video is the concrete shall be impervious, no matter what kind of the measures you take for this concrete. The concrete is a very heterogeneous material, and you can never expect you can have 100% impermeable. You all concrete is a pervious, so you can expect a pervious, but our condition itself says that the concrete shall be, so you have to have some kind of a layer between the surface of the water and the concrete, where the pervious layer will stop the permeability of the concrete. And the second principle is, what is the ductility? So to avoid cracking, ductility I've shown there, but what is the ductility and what is its why it is taken as a principle? Ductility is the property of the material which undergoes a deformation even without a stress, even without an increase in the stress. So when you have a ductility, then you have a water tank bulging or something. It shows uh, it shows some signs that it's collapsing. So when you have this ductility in the water tank, you should not show any signs of cracks. And any signs of cracks, if you see any cracks there, it says that the water will come out from it. So it's again in a huge catastrophic alarm. So in these two principles, first we need to consider, but actually it is impossible to have impossible. So we have so many methods to improve the concrete that you have studied in concrete technology. So then we have a construction joints. What are the types of joints and how we do? We have three types. When temperature is a contraction, when these things happen, temperature changes. So based upon this, these are made of, and also a retaining wall. If you take for rectangular shape, something like that. So this is the plan which I'm drawing here. And inside you have water. Now if you cut the cross section of it, it may be looking like this. Now you have a water here. Well, let us say for height h. And you have a same kind of a force which we have done in the retaining walls design, but here there the soil is there, but the difference is we have here a water. The even the water have the same kind of a pressure variation. Here is WH, and the total pressure you can calculate as half the total pressure. So when you are constructing this, you happen to have some kind of a joint. You cannot have a completely uh, b- uh, section of the concrete constructed in a single way. First, we do concreting for slab, then we go for this retaining wall, the side walls. So slab and then side walls. The problem is that we always have this the non problem of getting uh, joints which are not uh, fully um, cemented together. So we need to have joints in a such a way these are completely free in order to uh, completely completely in such a way that joint should not allow any water to seep through it. So that is our intention. If that is the main your criteria, that is called as a complete contraction joint. And some contraction some joints which you are expected to seepage of water, then it's called a partial contraction joint. Then you have a sliding joint of it's the water seeps through even though if you are not providing any joints. So we have a complete contraction joint, then you have a complete partial contraction joint. So the design consideration and all those things will design in the next class. Thank you.